Good afternoon, everyone. Thank you for being here. I welcome you all back to the fourth expert talk of SK EduCon 2020, India's first digital youth conference for architecture students. I am Nomeshwari, studying architecture in Sri Venkateshwara College of Architecture, currently in my 7th semester. I am the co-team member of SK EduTech Foundation. So today we are pleased to welcome engineer cum architect Dr. S.P.Anchuri sir, a very special speaker from Telangana. But before we begin with the full introduction of this expert speaker and about the type of knowledge he's going to share us, let us go through a small important disclaimer. So this event is a proprietary to SK EduTech Foundation. Everything shared here is confidential and proprietary. Sharing, copying, reproduction, distribution, and or recording, as well as screen captures without written consent are prohibited. Contents and discussions are also considered confidential. Please ask questions using the link shared. We will answer all your questions at the end of the session. So in this expert talk session of SK EduTech EdCon 2020, we have a person who's a triple graduate and a triple postgraduate in civil engineering, architectural engineering, business administration, structural engineering, and concrete construction management, respectively from reputed institutions. That person is none other than engineer cum architect, Dr. S.P.Anchuri. Anchuri sir is a chief consultant of Anchuri Consultancy. So this Anchuri Consultancy is a 25-year-old firm having offices in Hyderabad, Guntur, and Vizag. This firm is responsible for designing more than 1,200 buildings with integrated architectural and structural design approach. And today, he will be sharing with us his expert opinion on structures in architecture. The expert speaker being very passionate in bridging the division between architecture and structural engineering, this interactive session emphasizes on the understanding of essential relationship between structure and architecture of the building. Without taking much time, I would like to invite engineer cum architect Dr. S.P.Anchuri sir to share his knowledge on today's expert talk session. Thank you. Over to you, Anchuri sir.
Yeah, thank you. Let me share the screen first and are you able to see that?
Yes, sir, we are able to see the screen.
Great. Ladies and gentlemen and boys and girls, Namaste once again. For the better bandwidth, I think I just close my video for some time. Let me see. Now, yeah. Friends, as introduced, I'm going to talk about the structure in architecture. Normally, for architectural students, I speak about structure in architecture, and for structural engineering students, I talk about architecture in structure. So basically, when it comes to the structures in architecture, generally, friends, we say what the architecture is considered as a art. But for me, it's not just piece of the art. To me, the architecture is not just primarily the solution of problem, but making a statement. So basically, the form which is or the configuration of something, and the structure, the arrangement of the and the relationship between the elements of the object. Basically, the structure has different elements. So it's not just architecture and structure, but architecture has so many things within, that may be sometimes natural and sometimes man-made. So basically, when it comes to the historical perspective, since yesterday you might have heard many experts, right from the history to the present day, how it came and all. But friends, when it comes to the architecture, if you see the ancient days or olden days, we used to have only one person who used to do the entire work, that is architectural work, in addition to all other things, and we used to call as master builder. So the master builder used to undertake entire thing, and so in that, right from the planning designing, execution, operation, and maintenance. So everywhere we started with the concept, but we had built-in the concept of structures. It was not, at that time we never had, engineering as a separate thing. So when the industrialization came, when the when the revolution came, then the specialization came, and then we started having these entire divisions. But basically, when it comes to the what to say perspective, we need to understand. We need to understand the architecture as a part of the human civilization, and accordingly, we need to go ahead, friends. As I said, what the question mark is big. Architecture is not just planning or some aesthetics and all, but why, when, what, where, and how. We need to understand these things, because you can see the ancient temples, and this particular thing we designed one of the project in Vijayanagaram, where we understood right from the mythological aspects to structural aspects and all other related what to say connected things. So it's not just one or two elements, but it's the integrated design approach. And when for the students, right from the first year to the final year, before coming out for the practical training, we need to understand all these things. What is the behavior of the material, what is the behavior of the human being, those who are going to occupy that, or the functional requirements. So we need to understand each and every component, and we need to give the importance to everything. It's not just climatology, it's not just material, but the structure. Structure is the integrated part of that. So which comes first, structure or architecture? Definitely architecture, because structure follows. So we need to understand the importance of the structure in architecture and go with that. So what I will try to do is, quickly, for about 25 to 30 minutes, I will just we all sail through the slides where I try to explain how the things are required. Basically, what we think, whenever I go to the college for the lecture or talking to the students, they always say, no, engineering is full of mathematics, and I think we need to little go away from the mathematics, and then we join this particular architecture. But friends, everywhere mathematics is there. Mathematics is required for what? The calculation or application or inspiration. We need to understand that. And when it comes to the the need of mathematics, then why? There are about 5 major things why we need maths in architecture. So basically, the art, architecture, and structure, everywhere mathematics is required. Just for example, if you take the example of the converting the units, all over world, the units are different. So for example, somewhere millimeters, somewhere feet, and some limbs or kgs. We need to understand the units. Otherwise, you can't even work on that. So to know mathematics, it's very important to have this conversion tools. And what happens, say for example, figure out the scale. Now, when it comes to the figure out the scale, right from the first semester or second semester, we draw some drawings where we used to have 1:100, 1:200. That scale is very important. So that scale is important in the structure, with that scale is important in the architecture too. So that is one important thing. And then adjustment of the proportions, that is very important. And we heard about the golden ratio, that is 1:1.618. So here, when you think about this proportion, we must understand the mathematics again. So it's not something which is complicated. It's a very simple thing where you can have that. Now, the composed bill of quantities. Friends, I think in the 4th or the 6th semester, you need to know what is the bill of quantities, material required, breakups, cost, and tendering. And why this is important for the structures? Definitely, because the structural elements depends on the load coming over that depends on the form what you develop. So we need to have that knowledge of the calculation of the materials also. So that mathematics is required. And finally, the maths is required to create the complex yet functional forms. Now, what are they? That we see, as per me, when you think about the point, point has about 3 coordinates. Now, when point moves, that becomes line, isn't it? Now, when that line moves, that becomes a plane. And when that plane moves, that becomes a solid. So we are volumetric things. So we need to understand the movement of these particles and how we are creating this. Entire thing is a mathematical calculation. That particular thing we need to understand. Today we are creating the geometries in the using the software tools or digital tools, but still there also the coordinate system and other things are required. So it's a space taught, and we need to create our own world. So we must understand. And then it comes to the geometry, structure, and architecture. Friends, whether you are going for an airport design, whether you are going for a temple design, whether you are going for any type of a residential building, we need to understand what for we are designing that. So before taking up any work, I mean, I think in 2 days, other speakers, they might have told you how to go about the study of the architectural design. So as per me, the feasibility is the starting point of a project. Now, without feasibility, that may be in terms of constructability, that may be in terms of affordability, that may be in terms of the durability. So entire thing should have been studied in the beginning itself. That gives you to a good life cycle of the building. So functionality. Now, why the functionality is very much important for the structural design? Because if any space, whether I'm going to put a library in that particular area, whether I'm going to have a some kind of a storage or functional, that is what we are going to get the loading on that. So functional space is very important. And then technology. Now technology is so advanced. See, today we are printing the buildings. Today we are making the buildings at factory. So the technology which is required for the construction of that particular concept what you have developed is very much important. So we should update ourselves in terms of the methodology of the construction also. Then above all, the sustainability. Now sustainability is a buzzword, you know that. So today that's the need of the hour is sustainability. We need to sustain in terms of natural materials and natural resources. And then I think by this time in the final year, you might have understood that. Now the innovation, that is design, shape, and construction. Definitely, when it comes to the innovation, we must have some kind of attitude towards the creation of something. And many of the times what we see, the correct is beauty, but beauty is not always correct. Whatever you see good or beautiful, it may not be correct. So we need to understand what exactly we need to, what is correct and what is wrong. So apart from basic fundamental things, we must understand what is architecture and structure. Now, friends, when it comes to the structure in architecture, architecture is not just for the building. Architecture for everything. That may be aqueducts, that may be bridges, that may be canals, and cooling towers, dams, railways, roads, retaining walls, tunnels. Whatever you see in the metros also, metro rail and all, their architects are very much involved. Bridges are designed by, architects. So it's not the question of only building in the space, but we need to understand that. So the role of structure in architecture, or the architect's understanding of the structure, is very, very important. Architecture and structure goes parallelly. Now, for example, the relationship between the structure and architecture, we need to understand. The structure as a design, neglected structure, accepted structure, or the structure as a productive forms. This option we need to understand. Right from the construction to deconstruction. Now, deconstruction, so again, construction, we must understand, because the stages in the construction, The design in the construction, planning in the construction is very important. So sequential construction analysis is also important. When you come up with the, in childhood, we might have played, playing with the cards, that is art. In that we had architecture, even structural balancing. Now, the moment balance goes, entire thing falls down. So it's not something critical that we need to scare about the architecture and worry about the architecture at all. So we know how the things are right from the childhood. We balance ourselves. In fact, our body is also a system, the elements with lot of joints. So we need to understand the joints. The building is also a system with different joints. You might have, understood by this time what is the hinged joint, what is the fixed joint, what is the prop cantilever, what is the cantilever, and other things. So the same thing we need to follow. In fact, you see this particular pebbles are placed in the shape of the arch. Now, arch action. In arch, it's in the compression. The element is in the compression. So the member which is in the compression or only in the tension or bending or shear or torsion, we need to understand. So that depends on purely the behavior of that particular element, size, shape, and placement. So we must understand that. So this is the arch, and if I try to see these ancient, about the 2,000 years back, they have knowledge. They had the knowledge about this, action of the line action or volumetric action or area action, loads coming over that. So massive structures we had because the material available at that time was accordingly. Today we have reinforced concrete, we have pre-stressed concrete, prefabricated concrete, steel structures, composite structures because of the industrial revolution. But basically at that time, massive structures were there. Today we have more voids. If you compare with the pyramid of that time and the pyramid of this time, today's pyramid is hollow, but at that time it was solid. So we need to understand that and go with this. And when you go to the history of architecture, when you go to the case studies in the field, we must understand entire concept before going to the particular case study. For example, you may be going for the studying of the architectural elements. You may be going for the study of the structural system. We may be also studying the building services, what type of elevators are there, what type of escalators are there, what type of travelators are there. And these elements have different dead load, even vibrations. So those things are required to be considered by the structural engineer or the architect who gives the input in turn to the structure. And as I said, one of the finest example of the balanced, stable structure is pyramid, because this expression of the structure is a function. So here, as I was saying earlier, we had only solid mass, and today we have all hollow mass, taking out the material from the mass. We had wonderful temples, huge temples with tall structures. Today we are talking about the tallness. Today we are talking about the skyscrapers. But at that time, without computers, without construction equipments, they had that, and they with very zero tolerance they could achieve that, and they are standing still today. So it was structural design inbuilt. They had that knowledge of that, and they were not even having slide rule at that time. The slide rule, calculators, then today computers, supercomputers. So we need to understand the tools what they were using, basically the mind. Now, friends, architecture is not just, as I said, limited to the buildings, but bridges also. This is one of the finest bridges in the country. This is called as a Namaste signature bridge. This is in the form of the Namaste in Delhi across Yamuna. And all Indian architects and structural engineers, they were involved. In fact, Harshvardhan Subbarao from the Constuma, he was one of the main structural engineer, and Ratan Batlivai, he was the architect from Mumbai who designed this particular bridge. Now, friends, in childhood, we played in the sand. We created some kind of a hollow and took out the material from the sand and made this. This is also one structure. So this was inspired to, and this particular thing, Tadao Ando, who designed this particular, monumental thing, and you can see the resemblance of that particular, load path. So the inspired things, where, in fact, in particularly my buildings where I design maximum interiors, structure, and architecture integrated. I don't hide my structure. I try to keep my structural element open so that will create a beauty, that will create affordability, at the same time integrated thing. So this we need to understand. In fact, this is the staircase in my own house, which is a net zero plus building, where I try to utilize entire structural elements or forms as a aesthetic elements also. So that's what we can try to make it in the things. So basically, friends, it's very, very simple. When it comes to the architectural planning, you need to know the functional things and other things. But when it comes to the structural design, structural planning, we need to have column positions, we need to have beam positions, we need to put slab accordingly. So we'll have some kind of a horizontal elements, we will have some kind of a vertical elements, we will have some load carrying elements. So the assemblies of structural elements and non-structural elements will become a building. So here we need to understand what are the primary loads, maybe static load, maybe dynamic load. Now, dynamic load means varying load, and static load, we know that, and it's a gravity load. For example, dead load, live load, those are all static loads. But horizontal loads, so that may be wind load, that may be earthquake load. So these loads, lateral loads, create some kind of instability to the structure. So when you are having this project work or thesis work, we need to understand how these particular shapes and forms are going to make your building complex. So we need to understand that. So here, when it comes to the structural optimization for a new, today we have a digital tools. Today we can use a topology optimization in the architecture. So in fact, biomimicry, or when you see the spider web and other things, no doubt, we need to understand biomimicry. We need to understand how that thing is formed, how the load path is there, so how they made it. In fact, when we study this biomimicry and biomimic structures, we need to understand that particular element is made for that particular, say for example, honeybee, spider. So here, human being, they have different variety of functions. See, we need to have office, we need to have transportation, we need to have home. Activities are different, so the spaces are different, the forms are different, but the load path is going to be same. So we need to understand that and optimize it. So when you study, so there are some permanent structures, there are some temporary structures. Now, when the thing comes to the temporary structures, we need to understand how the path comes and how the construction goes. And see, for me, a building is having a good envelope where, say, side envelopes, and then that will be covered with the roof. Now, the roof will have different types. In this, you can see the roof shapes are different. And when it comes to the proposal of your thesis work or project work, when you are conceptualizing the things, we need to have some kind of a roofing, some kind of a cover. That particular roofing will have the spans based on your function, whether it's a auditorium, whether it's a hospital building. So what spans are required? So based on the spans, see, very simple thing, for horizontal, deflection is important. For the vertical thing, drift is important. The vertical thing with the fixed support can be like a tree. So horizontal thing, just simply supported or fixed supported cantilever, we need to know the bending action. So accordingly, we can decide the roofs. See here, just for the example, I have taken one floor system where you can have, say, for example, one-way concrete band slab. Here we can have only one-way banded beams, and columns. Then next, we have some kind of a band beam and joist floor system. Basically for steel structures, we will go for this. And here we have one-way concrete joist slab floor system. And then we have one-way concrete slab and beam floor system. So they're all moment resisting frames. So here one-way solid slab with the floor system. And then we have a plate with the columns. You know, when it comes with the slab, it's a plate transferring the load to the columns. So again, to avoid the punching, we go for the drops or capitals at the top of the column to have more resistance. And then we have two-way slabs with the floor system. And then we have waffle slab. You know, if you go for the long span structure, we have a grid of the beam and we can go for the waffle slab. So basically, if your spans are increased, then we need to go for particular type of structure. So while planning your project, you know, at third year or fourth year level, you need to just understand the spanning, how the slab load or the roof load is or floor load is going to go to the beam, from beam to how it's going to go to the column, and from columns to the foundation. So that load path we need to understand. So basically, when I say the triangle, this is one of the best method to transfer the load. So less of a bending and more of a compression. So your structure is going to look good, and then we need to have the angle. The more the angle, safer the things. But we need to have the clearness of that. This is one example. This particular pyramid is in my house, where I have used the huge pyramid in the atrium, where the action is towards the supports, and then I have divided the panels to the required sizes, and then that path is accordingly. Now, architecture is not just what to say. Materials is also very important. We are having so many advances in the materials, because when you had Stonehenge time, stone was there, then glass, then steel. You know, so today we have so many different varieties of material. We need to know which is good in compression, which is good in tension, which is good in torsion, which is good in shear. So accordingly, you can go for the material. So once you decide the spans, once you decide the structural system, that particular thing goes parallel to the material. So we need to know what are the different materials available. So apart from, say, you are studying the construction technology and material in the fourth or fifth semester, we need to understand why you are studying. Whether that may be, for example, aerogel, which is new one. Then we have the translucent concrete. Friends, we are working in the field of the concrete. There are about 70 types concrete available in the market. In fact, this what we are saying is a transparent concrete. So you can have load bearing transparent system. So we need to understand how that comes. Now, bacteria building blocks, different blocks they are making, and even concrete that lasts for long. When if you are constructing in somewhere, moon or something, we are thinking of going to moon also. So we need to understand the material. So once you understand the material, you can have the ease to design the structure. Now, this particular bendable concrete, when you can bend the concrete, naturally you can create the more forms. And if you have seen the parametric nature of the design, we need to have the complex geometry or the ease of work while even executing it. So these kind of new materials can have the plus point of that. This is one kind of a flexi comb which is available now. We can use easily in the structures. Now, kinetic glass. The glass is going to be a external facade. When you can't say just specify and use glass. We need to know what type of glasses are there. Structural glazing we need to understand. It's not like a window opening and all. So entire outer envelope is going to be a non-structural and structural element. And new codal provisions, they are very much clear about the usage of glass in terms of earthquake resistance and in terms of wind loading. So if you are going for a highly, Visakhapatnam or somewhere Mumbai, where the wind load is more, you can't specify a regular type of glass. We need to have some kind of a laminated glass, toughened glass. We need to know the parameters of the glass. So that can replace your just columns and beams and all. So solar cells we are having, and then concrete recycling we can do. So recycled materials we can do. Polymers are there. You can create any shape. Now, when you are having some kind of a new idea, the polymers, it's not like only cement, cementitious materials are there. So you can make any form, any geometry. So don't worry about the structural system, because you are not going to design the things. You should know the behavior of the structural elements. You should know how the joints are going to behave, or how the connections are required. That's it. So no fear while going for the structural system or structural design part of the things. So many of the people, they are thinking of the tall structures, that may be tall towers, that may be water tanks or chimneys, any functional where the space is less, you are going vertically. So vertically, see, when it goes vertically, we have a problem of the sway. So even Burj Khalifa, it sways. So the minimum the sway, the maximum utilization of the areas. In the world, about 60 to 65% of the vertical we are using, but other than that 30-40% we are losing. So we need to make that building in such a way that you have a very less kind of a drift. So the structural systems utilized for the tall structures, say up to the 10 to 12 stories, we have semi-rigid building, then rigid building, then framed buildings, cores, then shear walls, then tubes, bundle tubes, outriggers. These all the systems are available for the structural systems which are proven, and we need to know what are those available and what you can do the development. So based on the case studies, based on your future projections or proposals, you can just think of that. Friends, we know the digital world is in the front. So it's not only architectural, it's everywhere. In medical science is there, in structural design it's there, in mechanical it is there. So everything has to be interlinked. Here the real scenario starts, real challenge starts. You may be creating some kind of a facade, you may be creating some kind of form, but how to execute it? So the structural designer or engineering background people, they need to understand your geometry, how you are creating it. Now, the interface between the softwares, the interlinking between the softwares, you can transfer your geometry to the structural design software or their digital processing systems. So here you can see how these buildings, knowingly, unknowingly, you have seen and enjoy, and you are that's excited for your particular eyes. But these things are twisters, where these buildings are formed. The angle twisters and sliding twisters, and then it comes to the extruder. Many of you know how to extrude the geometry in the software, but then the same thing they are doing. When you extrude that, and then the elements are then added, and then physical and other properties are given there, and then we select the material. It's very simple to generate, but very complex to analyze. But again, it becomes a simpler if you go for the sequential analysis. So here, rotors, hyperboloid, boloid. So whatever you are hearing, pyramids, everything is applicable. So application is very important. And here, more than a mathematical calculations, your imaginary things or your logical thinking or your understanding of the behavior of that particular surface or element is very important. And here, the transformers. Naturally, if somebody wants to go for a free form, yes, we can go for free form. We need that kind of things in the modern world because those things are in demand. But at the same time, we need to understand the complexities of that. So these are some kind of buildings where futuristic things are there. In another 5 minutes, I think I will just try to close it. Here, the Zaha Hadid, you know how she is fascinated with the shapes and forms, and how she is clear about the ideas. The things can be formed. Kalantrava, his forms, how he gets inspired. Now here, this is Ramanarayanam, where our entire family was involved in the design of this particular mythological park, where we had interaction with across the stakeholders of the system. This is the longest span convention center where the steel and geometry can be together. This is one of the sustainable tile shop, where they can display the material. Right, it's not only tile; it's a flooring material that maybe big marble tiles or granite tiles. These things are kept there, keeping the requirement of lighting condition in mind. So inspiration from the architecture. Yes, architecture can inspire others also. Normally we get inspired from others, but here you can see the dress designers can inspire from the architects, architectural outcomes. So it's a mutual, this is one kind of a mimicry where they follow us. And in fact, today we are following what? So this in fact, today we have the torn jeans. I don't know how that person got the aspiration or inspiration. I think there also are this kind of dilapidated buildings are the future for them. Climatical architects turned architect design climate friendly buildings. So the same architect turned into dress designer, and he has designed this particular thing. So here, entire principle of architecture you can see. And now, as you see, this is your conceptual stage, and this is real stage. Here, a lot of things go, in that may be building services, that may be building structural system and all. So here we need to understand the optimization. Friends, structure and then the execution. So execution, we have prefabrication, we have slip forming, we have top-down construction, we have modular construction. So these construction methodology can be applicable based on your creation. So based on your method of execution required. So there is no limitation for any thinking. So go out of the box and think whatever you can do, whatever you can put on the paper, that can be done. So here only the request is don't go directly to the digital world or digital platform. You take pen and pencil and paper. You try to put whatever you think on the two-dimensional thing or three-dimensional on the paper. Then you go digital, and then you can create the wonders. And in between, so writing with the pencil and typing with the keyboard, it's a lot of differences there. We need to go by step. So printing of the building, yes, we can do. Contour crafting is one of the best an upcoming thing. And we need to understand the two things. One is substructure, and another is superstructure. See, without substructure, superstructure is not there. Now, superstructure can be same within the kilometer area, but cannot be same in the different regions. Kashmir, I can't construct the same building what I construct in Nagpur. But at the same time, substructure. So soil conditions differs. In my colony, it may be loose, but in another, after 2 kilometers, it may be rocky. So substructure varies, superstructure varies. So we need to understand right from the feasibility of the structure. You can't have multiple basements in the rocky area. You can't have only structure starting from the just like ground level at the black cotton soil. So we need to understand that. Now this Stonehenge, the inspiration came to one architect who did this Sam Sky Tower. Now, this particular project is by my daughter who studied, in SPA, JNF last year architecture. And with the integrated approach, she could do this dynamic tower, or she could do this entirely mixed use, where the structure, architecture, and building services and materials, entire thing was a challenge. So we can do it if properly things are there. And this is one elevator in my house, which is again steel structure. These are all structural based architectural outputs. And vertical, yes, when you go for vertical, drift is a point very important. You can't have a sway like this because Empire State sways by 1.5 meters. So we need to understand how the structural systems are required, how the structural optimizations are required, what shapes make that particular structural system stiff and stable and suitable for that particular thing. Friends, I always compare the body building body, balance, the same weight, same thing, you are going to try that. The center of gravity of that particular system or changed shape should match with the center of gravity of the base. So that gives you a balanced structure. So there is no fear about that. Now, for example, here everybody is standing in the same position. Your building enclosure or your skin or your whatever say clothing is changed. So that is what the facade design is. Now here I did some research in the tall structures where I tried to reduce the drift and maximize the uses of the tall structure. Friends, when you stand straight, you may be swaying. When you have the legs or your foot spread, then you can't have that sway. So straight foot methodology is one of the best way, or conical shapes and other shapes are also proven methods to create to reduce the drift. So reducing the drift means increasing the comfort, increasing the affordability, feasibility, economy, like that. So these are some things where you can have analysis and compare this. But this part is entirely by structural engineers based on the architectural input, they will do it. Friends, architecture is a synthetic and collaborative profession. Here, it's not only structure. The moment I want to put some kind of a fire fighting equipment on the top or water tank required for the fire on top, then again I need to know what is the weight, what is the requirement. So here is a leader. So you need to understand each concept. And friends, don't worry about the calculations. You see, you are having an electrical plan, you are doing plumbing plan, you are not going to in depth of the design, but structure is integrated in that. So somehow right from the beginning, if when I compare with the other subjects, little see, if you are having a fear about that, naturally you will be little away. That is what is happening with the even teachers. So they are not trying to focus on that particular thing. Some kind of a civil engineering based or structural engineering based professors are coming and then they are interacting and they are telling, so what is the bending moment? See, knowing one thing is important, calculating. For calculating, there are so many softwares. But by this time, you should understand how the loads act, how the bending is created, compression, how that can be resisted, tension, shear, and torsion. So we need to understand that. In conclusion, see, for friends, architectural planning or architects are worried about the sun path, orientation of the building, because everything will be based on the sun path. And structural engineering, load path. What is that load path? Right from the, say, due to gravity, entire thing is going to go to the ground. If whatever you are going to put on the top, it ultimately goes to the ground. It has to resist. So right from the superstructure loads to the substructure resisting capacity, you need to know the flow. That may be vertical flow, that may be horizontal. So how that, when I push, how that particular body, that's what I always say. When you are standing, you just try to do some exercise. That may be yoga, that may be some kind of dance, but your body is same. The joints are same. The elements are same, but the way you get strain, the way you get stress, you need to understand. So that is what the building is. So building should be also designed as per the requirement of the resistance of that particular thing. And in this, another suggestion for all the students is maximum you participate in the conferences, in the lectures, interact with the people, not only with the professors, but the experts in the other field. Those who have done, say, good type of elevator systems, or those who have roofing system. So if you get opportunity, try to interact with the material scientists, try to interact with the structural engineers, try to interact with the HVAC engineers. So you need to understand how they are following outside in practice, and that particular thing will bring out your fear and you can integrate more. So right from the second or third year, I think you need to understand this, and which I did right from the beginning in all the stream, that may be management, that may be structural, that may be concrete. We need to see, you need to go, you need to apply, and we need to practice that. So that's what earlier I used to do it, and now it's only virtual. But sometimes this is also good. Even you are getting good time to learn, good time to see, because all youngsters, they are, they spend more on the screen, isn't it? Screen time. So why don't you make it more possible and go for this? So before I really conclude, it's not the men in the architecture, it's not the women in the architecture, but we need to have a human touch in the architecture. We can create some things which can be affordable, which can be stable, which can be durable, and which can be feasible for entire humanity. That should be your target, that should be your passion, that should be your practice, and that should be your profession. And in fact, to this stage where we are working on a different platforms, credit goes to everybody, my teachers, my students, my parents, and everybody. It's a teamwork, it's an integrated design approach. See, if my object works well, each element has to work, its perform its duty. Even structure, if I'm constructing a building, that may be beam, that may be column, that may be slam, that may be any part of the element of the structure, it has to participate in the load path. The things which take participation in the load path, that is active, which won't, that is passive. Our building should be passive, but our structure should be active. That is what I wanted to normally emphasize on that. And then I open this forum to the questions. But basically, friends, don't worry about the structure. Create any type of complex geometry that is possible, because if that is feasible on the paper, feasible on the I would say three-dimensional way, then why you can't? Because there are n number of things available in terms of material now. So we need to understand the material science, its behavior, and where to apply what. So what, where, when is to be known. Over to you, Sketch.
That was wonderful, sir. That was really good explanation, like the sun path, load, and human being. That gives a real clear view about the structures in architecture. So thank you so much, sir, for sharing with us some wonderful insights about this complex world of structures. So there are a lot of questions about this topic, sir, but I'll sum up with 3 to 4 questions, and the remaining questions we will mail you, sir, so that you can answer it when you get some free time, and we can post them in our Instagram page. So the first question is it really necessary for architecture students to learn about structure? As a student, I have seen many friends finding it difficulty to understand the subject. So what would you advise them?
See, learning structure is very important, because when you see, for example, that's what I am comparing with the human body. Now, when you are designing some kind of a body, it should stand, it should be stable. So when you think of a structural element, then made of what? See, for example, rope is different, pipe is different, and the bar is different. Bar is solid, rope is solid but flexible. Pipe is hollow, but again it has its stiffness. So what you are planning, you can't just draw a circular column, you can't draw a rectangular column. Say, for example, if you have bending in more bending in one action, then your column will be rectangular. If you are having this both ways or always same bending, then you have a circular. So to even know the shape of the structural, I mean, that particular column or beam or whatever it is, you need to understand. So you are trying to understand the load going to create the forces. So once you understand that, that is good enough. So it's not that you are going to calculate bending moments, shear forces. Then for that, civil engineers and structural engineers are available. But you need to understand at this stage what creates the bending. If I say, for example, if I rotate this creates torsion. So you need to understand pulling, tension, compression, and pressing, compression. That's good enough. So it's, see, don't go away from the elemental thing. Basic things you must understand. So analytical thing, naturally that comes by the experts. So you need to go for that.
Yes, sir. And The second question is, these days students really want to experiment with different forms, but there will be so much transformation from concept level to jury level. Students were failing to keep as it is when they thought at the concept level. So what will you suggest for students who are facing difficulties at that point?
Yeah. See, the first thing is your guide, those who supervise your work. See, basically, when you are coming with some idea, see, I will give a small example. One of the student, he was he just came running to me, and he says, "Sir, my teacher is not accepting this particular structure." I said, "What?" I designed a floating building, floating building, and my teacher says, "How it will float?" Then I said, "It's very simple. 5-star cushions. I mean, this ships. Why you are not given an example of ship? You are floating the building. There, it's entirely turbulent area." Then he got that, and then he explained that. So basically, we need to make the teacher understand. See, what happens is when I studied my first graduation, because I have a couple of degrees, initially 4-meter span was huge. Today we are designing about 20 meters, 30 meters, 40 meters. So the technology is there. So how to apply that, what creates that particular shape, and how can it, see, make a model. Physical model is very important. Instead of virtual modeling, instead of see, one of the best idea to know the geometry or how the that behaves, you go for a paper models. If you go for a physical models, don't touch these digital tools at this stage. Even if you create, go for a prototype model. If that stands, definitely that stands. It's only resemblance of that particular thing. And when it comes to the thickness and other things, you have some kind of assumptions. Say, for example, 4-meter slab, what should be thickness? 10 meters what slab thickness. That's all. So we have technologies like post tensioning. We have technologies like pre-tensioning, pre-stress things. We can just browse. You can just click it. 20-meter span. Your teacher says no, it's not possible. Just click it. You have a post-tension technology. You can say that post-tensioning methodology can be used for this 20-meter span, and you write some kind of feasibility. That's what you have, this feasibility report. I have seen hardly anybody who's giving importance to the feasibility report. So feasibility, affordability, of the architectural function is one, but the structural feasibility, you just try to understand. You will be clear with that, and your teacher and the person who is coming as a external, structural expert, he will be knowing that, because he will encourage that particular concept of complex things. Complex things are complex, but make it simple. Think in a finite element way, you will be getting it.
Yes, sir, absolutely. Proper justification and detailing. Yes, sir. So we have almost 15 questions, sir, but we are lack of time. We will mail you, so please feel free to answer them. So thank you so much, sir. It was really indeed very
So
thoughtful
before
to
I
go
conclude,
through an
say
enlightening.
whether it's a Kashmir, see, just try to understand whether it's a Kashmir, there is a Kanyakumari, or anywhere in the globe, we are, we are having gravity. If gravity is not there, we won't be on the earth, isn't it? So entire load is going to transfer towards the earth only. So you just try to understand that how it is transferred. That's all. That's the only thing you have to learn, and you have to explain. There is no limitation for your thinking. Come out of the box, come out of the fear, and take the help of the professionals, take the help of the teachers, and have guest lectures, browse, and come up with the ideas. That is what our next lecture will be. Biomimic. I think do they have any knowledge of calculations? The animals are having, or birds or bees, they are having these softwares. No. So they are doing entire thing because they know what they are going to do and what for they are doing, and they are understanding what people they did. So here we need to do a lot of case studies and go ahead with this. All the best.
Thank you so much, sir, for being here today. It was so splendid for us. And so the next session, which is an expert talk by architect Yatin Pandya, sir, it was inspired by nature, that will start at 4:30 p.m. So for feedbacks related to this expert talk, please scan the QR code displayed on the screen, or otherwise you can check the link in the description, and you can give us a feedback over there. Also, do check out our Instagram handle, Sketch India, where there are a lot of students' talents got exposed, and also follow it for the further updates of architectural student organization. Thank you so much, sir. Thank you.
Thank you.
You will be live in few minutes. Yeah, you're live.
Okay. Welcome back, ladies and gentlemen, and my dear friends. This is Shravani Kisara, an architecture student of 7th semester from Sri Venkateswara College of Architecture, Hyderabad. Firstly, thanks to everyone who stuck with us patiently till now. Before I introduce you all to today's session and the speaker who we have with us, let us run through an important disclaimer. This event is proprietary to A-Sketch EdTech Foundation. Everything shared here is confidential and proprietary. Sharing, copying, reproduction, distribution, and or recording as well as screen captures without written consent is prohibited. Contents and discussions are also considered confidential. Please ask questions using the link shared. We will answer all the questions at the end of the session. It's an honor for me to take this opportunity to introduce our expert speaker, Architect Yatin Pandya, sir. Architect Yatin, sir, is based out of Ahmedabad and is not just an architect, but also an author, activist, academician, and also a researcher. He is famous for exploring kinesthetics in his projects and research alike. After graduating from SET University and completing masters from McGill University, Canada, Yatin sir started practicing architecture through his firm named Footprints Earth, where Earth stands for Environment, Architecture, Research, Technology, Housing. Without wasting much time, sir, we would like to invite you to share your knowledge on the topic inspired by nature.
Namaskar, very good evening. Honored to be here. And thanks for being here on Sunday evening. I'm sure you have too many better things to do with festivities approaching. But nonetheless, thank you. Thank you for having me here. What I'm going to do is to share some of the thoughts and interpretations on terms like nature, sustainability, ways of life, and green, and etc. I'm just saying a very fundamental kind of position here that any existence is about two equilibriums. One, human to human, because we are an aspect of society, and another important one is human to nature or environment, whatever you call them as, because we are a part of it and we only sustain through that. So it's very important, very basic, and very fundamental for any existence to be in harmony with nature. So what I'm saying is nothing to kind of drive home about. It's just simply that in our field, how do we actually manage to realize or do that? So it's more in that count, and especially as the title says, that how can that become our way of life? So it's not a formula, it's not some kind of a science or technology, but it's simply the way we live and way we live with nature, and nature comes in much larger package than what we think. And what kind of, therefore, context such as India derives our architectural syntax for. And just to jump to the carry back message, I'm putting up front so you can judge all my saying through some such yardsticks, that in India we have accumulated wisdom of 6,500 years, and those have, even transcending time and space, proven their word. So if we can apply those principles, so inspire from yesterday and aspire for tomorrow is the kind of takeaway. Now, in this pandemic time, in a way, it's become simpler if we simply were able to look into the mirror, look at our own selves. You know, that pandemic did a few wonderful things. One, equality, you know, all had been put on the same plane, whether it was, and in fact, one of the pandemic that came from top down rather than bottom up. It taught us humility, frugality, plurality, sustainability, and taught us, more importantly, that we are not the master of nature, but we are a microcosm of the larger cosmos, and therefore living with nature is what we ought to do. And if we do that, it also very easily and very quickly demonstrated, which nobody would have believed if this didn't happen. That we always thought that we are probably too many people on this planet, and now this is gone case. Nothing can be done about it. But just, I think, 4, 5, 6 weeks of staying in and undue systems. Everybody survived. Everybody had their basic things going on, but some undue systems put away from the kind of consumption. And we could see that nature corrected its own course, whether it was air that purified, even in place like Delhi, the pollution that decreased and you were able to see far off, the kind of water cleaned in itself, and most again strangely, all the kind of other creatures that were shut down into their own den, they found that the whole world is their den, and they came out. So in other words, if we can turn this calamity into a virtue in terms of
I'm really sorry to interrupt you.
yeah.
We're not able to view your presentation, so can you screen share again?
Oh, so that's what I think we must. Okay, let me go back.
Yes, sir. Really sorry.
Is it happening now?
No,
Are
sir, we're
you
not able to view it.
just cross-checked? Okay.
Can you screen share it again, sir? Probably there was an issue.
Right, it says is it happening?
It says you are screen sharing, but we're not able to see anything.
It's already there on my page. 1 sec. Let me go again. Have you given permission to? Because earlier I'd got that if other one is going on, you can't.
Yes, sir. Yeah, now we can see it, sir.
Okay. So
Yeah.
control there.
Please continue, sir.
Okay, so anyways, this is some introductory slide, as I said, that how nature taught us humility, and these were the kind of outcome that we saw, what happened by nature correcting its own course, and therefore, if we're able to kind of turn this constraint into a virtue and take a pause and take a pledge, that how do we learn to live with nature? And we have learned the difference between need versus the excess, so essential versus excess, and if we can go by that. So what we need to reflect on is that we were talking about smart city, but if this is the kind of image or an idea of what we might want to think of or define smart city as, then we need to really take a pause and understand, is it a slogan or a vision? What I were to drive through is that if in the whole world people dress differently meaning appropriate to their own place and the weather, the nature, or whatever. People tend to be different by skin color, by many other day-to-day routine. And of course, the food is different. This is how even architecture used to be different, that if I showed you this picture, even if I did not put these names, you would have not had difficulty guessing the material base, the technology base, as well as the cultural base and geographic base. But if I show you this picture, I don't think it's easy to guess that even as diverse climatic and cultural centers would also have exactly the same expression. And why only India? If you put any name from the city of the world or country of the world, this one works through. So we need to therefore pause and think what Kerala should be there for us for future, what Jaipur are you longing for, and what Kolkata should be our benchmark, So this is where my first, title takeaway that said that, learn from yesterday and aspire for tomorrow, or inspire from yesterday and aspire for tomorrow, comes from this that in Indian context, we live yesterday, even today, and that becomes the basis for tomorrow. There's a difference between history and tradition. And this I also put up front because often when we use the word tradition in Indian mindset, it suddenly goes as if antiquity, tribal, back to the ages. No, what we're talking about is tradition as a present which has consolidated over the kind of constances from yesteryear. So history may be a dead tradition, but tradition is a living history. Now, when we say, therefore, this tradition of wearing a particular kind of attire, you know, there was a study done in Japan that if these executives were relieved of their formal dressing, ties, tuxedo, and allowed to wear casual, they would feel the same level of comfort with couple of degree warmer AC temperature. So it was the wrong dressing undue culprit for having to increase the energy consumption. So if people from coastal region, if they are bare chested, are they primitive or they are the most appropriately dressed for that particular context? We knew Gandhi, who knew when to, unveil and rap. Do we need that Shashwat Gandhi, or we need Gandhi to toe a line when it is fashionable to be what in cool in winter and hot in summer? So we must know when we are aping versus when we are adapting. And for that, the most important things are the norms and standards. And as architect, we are triply responsible in our act of doing things because one, to begin with, fundamentally, we are altering the existing landscape. Second, our energy, even the effort, energy consumption is highest compared to many other fields and disciplines, and equally high the resource consumption and thereby the pollutants. And third, what we create arguably lasts even beyond us, so even our mistakes perpetuate. So we need to be quite responsible in what we create. And for that, here is just some of the proof of what I was saying, that if 20% of the world's population consume nearly two-thirds energy, even 87% vehicles are simply owned by 20%, and three-quarters of water is consumed by this 20%. Who should be designing our base norms for? Should we be having vehicle as a basis and therefore make roads with carways, or we should provide for 80% of the walkers? So it's in that light, just to understand where the norms, despite good intention, can go wrong. For example, the top left here, it's an idea of a green laptop where it's like any other laptop. You additionally put one bamboo chip layer and you call it green. Mr. Wally Broecker, the same scientist that coined the term global warming, is doing $1 million project of oxygenating the planet by doing artificial tree-like looking installation. Could natural planting of trees not do it at no cost? So it's that what we need is the thing on the right. For example, these African children are happily taking turn and moving the merry-go-round, the round wheel, but that has been connected smartly to mechanically to the underground aquifer. So as they move, the aquifer water is drawn up and put into the tank at the back overhead, and thereby gravity 24/7 you get it. So can we not think of solutions of such sort? What kind of decisions? So we recently had a session on material and technique. Look at the energy costs. It's not the sale price that you get certain things at, but if you take unburnt brick to be a unit, By burning, your energy consumption goes twice. Cement is 10 times, steel is 30 times, aluminum is 160 times, In daytime, use building like commercial spaces or offices or whatnot, 92% of energy is simply spent in cooling and lighting. So if you can little tweak on that, like light in India is abundant, and if you can't use the daylight for daylighting, that's a crime, that's a pity. So something like this, where most of your energy is simply consumed in cooling the space, because this full glazing facade on this happens to be left is the south facing in Ahmedabad and the right is west facing in Ahmedabad. And you can imagine the kind of glare and the blaze. In fact, there was a recorded 3-degree warmer temperature because of the reflective glass. I mean, the glass which would reflect the sun, not only it would transmit inside, but it had reflected a glare on the footpath, and the footpath opposite this building was 3-degree warmer than the one around it, little away. So point is that technology may be a step, but after you taking a right design step. So for example, if your transparency of the glazing allows 100% transmittance of heat, by double glazing you can reduce by 10%, by XYZ phenomenal glasses, you can reduce by 60%. But simply in a design, if you have a meter wide awning, you can already reduce it by 75%. So what comes first is what we're talking about, that as architect, if we be aware and we take our design decisions into the first step, and then the accessories, and then the gadgetries, and so on and so forth. Like here, it's where we spend is more important and where we could save. It's not that we have to turn back and live like a primitive man. No, use electricity. But what is the logic of using hoardings with 72 fluorescent tubes running for 12 hours of night, which makes city ugly as hell? And at the same time, 300 houses could have been illuminated by that. And if we think that, we see this in other countries, they have been more smarter. This is a study of Montreal Urban Design Guideline, where they said that you can do whatever to your building, but being a cold place, it has a regulation to say that you have to ensure that you have 3 hours of sunshine on equinox day on the opposite footpath. You have to have 50% of the opening onto the open space for sun. So how do we design which can inspire and bring this awareness? Here's an example of a non-architectural product that says that, you can see here the switches, electrical switches. So as you put it on, it comes with a, very kind of a happy sign. But as it kind of works longer, it makes faces. Or here the coat, if you put in, it just opens up, and as you take away the coat, it shuts down. Even rethinking of a new avatar, a new generation. So like a beer bottle, after you're high in your spirits, you throw away. Way back in late 60s, early 70s, there was this Heineken beer bottle that had a kind of square serration, and it could work as a brick in the wall. So even in next life, it becomes a handy thing to use. Otherwise, you have even a problem of collecting it and so. And technology is not a preserve of the few. It's just a tool, and as long as it can improve the quality of life. For example, in a desert, if you have to run a photocell, it's not a contradiction or it's not a joke. It is just a way by which you can manage your things in that context. So sustainability is just a way of making contextual adjustment for improving the quality of life at the least cost. What are the tenets of sustainability? They're all of these that refuse, that reduce, the recycle, the regenerate, the reuse, the restore, etc. Let me run through some of the principles that we learn from traditional architecture. Now, when we say traditional, it's again not to say to turn clock backward, but if we learn principle, why? Purely because of their performance reasons, even today. They have come about in a pre-electricity days. And still, if they feel comfortable, what can we learn from that even today? That even if I want to use AC, maybe I can reduce the tonnage. So for example, one of the principle is the insulation through mass of the external envelope. Now, the moment I say mass, you would say, oh, today urban spaces are very pricey, they are very few. How can we spend this? No, turn this into a storage cupboard. Why can't external surfaces be a folded plate storage element which becomes a buffer and keeps the inside cool? Ventilation is as much a twin brother of insulation, because in our context, we don't need to warm up the place, we need to evacuate the heat. So even if it's a sealed environment, we are generating, even with our metabolism, the heat. Also, all our machines are generating heat, whether it's a fan or a computer. So we need to evacuate, and therefore, again, learning the principle of allowing by convective principle at upper level the ventilators and the kind of escape routes. We have abundance of light. In fact, sky component is extremely high, and therefore, if we learn to rely on some of these diffusion and yet a glare-free enough illumination. So not the glare, not the direct kind of a haze, but the illumination. So skylight is one idea. Jali fenestration of the kind with the punctures is the amazing idea, where culturally you could look one-way privacy. Inside you can look out, but from outside you can't look in. Then the idea of a Venturi's principle, where like even Mr. Laurie Baker applied it in present times, that as the air goes through a small aperture, it picks up velocity and it kind of reaches far. And similarly, Bernoulli's principle that it goes through a puncture, it also becomes micro cool in that sense. We had traditional homes with three-part window, top for ventilator, middle for view, lower for breeze, and as per your need, you could permute and combine these. So it was flexible and it worked for all climate and as per your cultural and privacy needs. Courtyard, my next book soon out, just because the lockdown's been delayed, is a 500-page book on cross-country courtyard houses of India. And all places, the DNA of typical house form is with courtyard. And courtyard, because of its principles, like what you see in diagram, evacuates the hot air, brings in the illumination, so cheerful, deep long houses, but ventilated as well as brightly daylit. And in case of Indian Ahmedabadi house, it also harvests rainwater. Roof, we forget, Bombay, we crib about space, but how many places we have been able to use roof successfully. And way back 70 years ago, Corbusier taught us that, you can grow. So it's not only cultural space, social place, it's functional and cultivable, so renewable place. Same way, vertical green. Again, Ahmedabad Mill Owners Association by Corbusier, and it was built in 54, so 67 years ago. And it was conceived as something that would add to not only the charm of the building, but also micropool, and you can grow things. So roof as a living space. And this is one example, Ahmedabad, where FSI of a plot is 2.7. So it is also a fallacy to think 11-story building, which goes everything anti-gravity, which has also got an elevator and stuff like that. So its energy consumption, maintenance need, and structural demands are very high. We were able to get, culturally, it's not the most suitable to our lifestyle, where 66% on ground we were able to use in this traditional quarters, and as high as 2.7 FSI, where in Ahmedabad, legal high-rise building till recently in most part is 11-story that takes 1.8. So even if the density is 1.5 times, we had answers 6 centuries ago of a typology that did that. And here is a quick comparison. You can see both of them have the same density, but one on the left has terraces to every floor, is culturally more significant, is giving you better urban form and climatically responsive versus these isolated needles. And this is what is the living environment we see of the traditional quarter, which has now got a UNESCO tag also, not for only building, but for the kind of lifestyle. So morning, afternoon, evening, as well as festivity, it's a multiply used space. So it's optimization of space over time. And look at the simple principle. Like here, you see this vertically projecting profile. So it's a deep, long house. So longer sides are shared with neighbor. So you don't have vagaries coming from there. and upper floors are gradually projecting. So when sun is overhead during the critical adverse time of the day, most of the thing is in the shade, and when sun goes low, the next side. So as a thumb rule, if you have a side shade and the top roof with another floor, you reduce the heat gain by almost 50%. And then with courtyard and this kind of windows, you could not only architecture, but as I say, way of life. All hot, dry climate places, we have the tradition of having the swings. What you do with electrical power, we used to do with the muscle power, and you can see the way swing gives you the perspiration and therefore the evaporative cooling of the body. So body comfort is maintained. And maybe I'm just kind of relating this in my own, but even the logic or the very quick thumb rule or the observation that warmer the climate, spicier the palate, like Telangana and all that, India per se, more spicier palate than something else in the Europe. So because of the tannin or whatever, you might perspire and do that. Now with these principles, just to give you one example of one kind of interpretation in our kind of practice at different scales. So how this can be applied at all scales. So we'll see different scales as one example and diverse approaches. I repeat, sustainability is not a formula. Nature is diverse everywhere. So it's like doctor curing the patient. He doesn't go by the pandemic. Any patient is not corona. So even the symptom of coughing and fever may not be corona. There could be chikungunya, there could be something else. So likewise, we have to know and treat each context, each program, each place, each person on its own. So one of the first and the least kind of thing we can do, and this is the project that won us the International Habitat Award as well, is to just you, but again, how it changes quality of life. This is what urban slums have been about, and we were asked to help them to get some light and ventilation in inner rooms. Deep long house without a courtyard. Inside is an oven and it's dark and dingy. And that's why we came up with a very basic answer like this, which could draw, translucent sheet could draw the light as well as it could with dormer allow for ventilation. And even some as basic, nobody gives you 5 paisa for empty water bottle, but put it in this manner, it could glow like a 60-watt bulb. So simple things like that. But what did it do? Every house, there is over year, a recorded saving of post-occupancy evolution, minimum 250 to 350 rupee monthly electricity bill saving in such small houses, and 1500 rupee increase in home-based economic production, plus the health index and education index, you can see improved. So simple installation as a design. Then a residence. This is the house that has been part of some 50 beautiful homes of India, whatever, for a wealthy person, but still principles can be applied. Ambani's house should have been the best case study in the world for sustainability. So just because you have money, you have no right to take away the world's resources, the nature's accumulated resource. So what are the principles? I'll go through. I'll not explain the building, but you will be able to see the principles. Natural, maintenance-free finishes for lifetime, no paint and what so, and local material, the brick as well as the overhangs. The massing has been designed with common sense that south and west have a larger projections and north and east could do with little less. So you can guess what side this is. Then water and vegetation for microclimate, and water is also recycled, harvested, etc. Natural palette of material. Here is water, including this right-hand side internal courtyard, which harvests rainwater, then the path water, then the roof water, etc. This is the courtyard, which basically is a formal drawing room, but its floor is essentially on top of the water tank, like traditional Ahmedabad homes. There's no false ceiling and yet enough modulation, and all this is natural light and natural ventilation that you see here. And courtyard, in today's context, people don't like monkeys to come in and rain to come in or dust to come in or thief to come in. So that doesn't mean you can't have courtyard. This is exactly naturally ventilated and illuminating courtyard. But by lifting it a little, you are able to get everything that a typical traditional courtyard got. Similarly, skylight and the ventilation. You don't have a chimney, even though they could afford 20 chimneys here. But I said, why? And that circular wall has a skylight like this, and then as a result, the smoke and the heat goes out, and you get a diffused, beautiful light. The play of light all through the day with the natural cutouts in the slab. So, like in a east and west on the left, it gives you a glow in the morning to wake you up, and the other one in the slab where the punctures and in the form of a bird in this case. So as they move, the light is dynamic and the birds kind of move around. And then giving patronage to the craftsmen. So it's unique to each house, it's particular to each house, and they get, so there's beautiful craftsmanship heritage that we have from India can continue, but they are also not only local, but climatically proven. For example, this China mosaic being clay, white and glossy is, giving you huge insulation for the roof. And of course, the new technology in terms of light and low energy devices and whatnot, there's no kind of contradiction in not using it, in using it in that sense. From that to a standalone commercial building, this is a corporate office on its own, but the principle, you can see it's the same building, but the facade or the form keeps changing by orientation. Let me show you here. The left-hand side, as you can guess, is a stair mast, and it's a natural but contemporary jali. It's a crossword puzzle for a publishing house. That's why it gives them an identity. This is where you enter from, but it's a naturally ventilated jali. All these letters are the punctures, so are the symbols. While the other one is a south one, and south you have a little harsher sun. So these have been the kind of laser cut jalis in stone and other materials, and it has been just picking up to remind as a corporate house, Ahmedabad as a local address, and these are the kind of jalis from heritage structures of in Ahmedabad. And right hand side is southwest, where we have this contradiction that west is very good for breeze, but southwest that is, but bad for sun. So how do you reconcile? If you put fixed glazing, if you put 100% opaque, then you don't get breeze either. So here operable louvers with a layer of vegetation in front. So this is how, and the other one was the north and east, northeast. So that's why it's liberty to take a little more glazing, because it's more a kind of a particular activity area. You can see planting at every floor, even in a commercial space. So it's just the principle that we need to know, and you can apply it. These are how they therefore look, even with the changing light and this interactive kind of puzzles as a jali, etc. This one is the idea of recycling the waste material. And as you can see here, that it is the domestic and municipal waste, which otherwise gets thrown. Ahmedabad has, as a city alone, 2,600 metric ton of waste it produces every day. And it's simply thrown, and we have 70 feet tall mountain, which never existed. It's just the dump yard, and it's growing. So simply as a architect, not as a technologist, but we tried to apply, we studied as many houses, 300 homes of the squatters to understand what kind of secondary material were they using, and we still can improve or make a difference. So we put a benchmark that it would not be more expensive than what otherwise from secondary market or whatever they are using. It would be better performing, as well as it would be kind of stronger or aesthetically more pleasing. So one set of things we used was fly ash brick, but with a little different, rather than a sand, it was the backfill material from the dump field site. Waste residue from a dump field site is a 75 paisa brick instead of 3.5. Then, even in a dry state, there are enough liquor bottles, and we were able to kind of put it as jali, put it as a waste facing facade, so it diffuses light, and so on and so forth. So, again, that is where the design sense comes in play. It could have been used anywhere, but, western sun is so low that no amount of overhang would cut it down. So that's why stained kind of glazing there would do. And at the same time, I just said a while ago that southwest and west is the direction for breeze, and therefore this allows for breeze and yet cut down on the glare, and it grows beautifully. So while we have this picture from the slum where we applied, but I've also used it in a rich person's housing in bungalow or so. So this is another approach of recycling, so to say. As I said, nobody gives you 5 paisa for water bottles, and they are in thousands. You know, the statistics is that in America, uh, 15,000 bottles every second get thrown out. And when we have parties, we are not behind. So here is a plastic bottle with widows of the slum earning livelihood by singing bhajan at night, just with a thumb pressure, filling it with inert material, have created this waste which would have been just lying for years around, has actually become a resource equivalent of 2.5 rupee as a brick in the wall. They got employment that is extra, and the pollution was cured that was even extra. This is rack sandwiched FRP panel. The left hand side is the tetrahedral pack and some of those not paper, not plastic kind of material, packaging material like we have now Diwali, your you know Cadbury wrappers. They are neither paper nor plastic, and they don't disintegrate. So they have been put in fiber reinforced plastics to substitute glass wool for the kind of bonding. Here is a galvanized iron sheet of oil container which is opened up to become paneling. Same can become louvers, ventilators. This is a metal scrap. You know, this is not a designed, preconceived pattern. We just got a scrap at a nominal price or somebody's throwaway, and we just used it on spot to say, and we could make this interactive door with wheels moving from the cycle part, some fun aspect, some, like this space upside down or sideways, you can see. This is the waste from the, construction site where you have to pay money to get it offloaded from your site and they simply dump somewhere. Here we use that as a resource, and just by adding a design value, we were able to make interactive flooring in a crash where children crawl on the floor, and they could be even using this as a teaching environment. Same way, digital waste and turned into a sort of a paneling, etc. We even have a kind of a filler slab on top used with digital things. And this is how the spaces are used in a slum, naturally ventilated. And look at the quality of life change. That's what I'm saying. Design to improve the quality of life. Not only it's used as a school in the morning, afternoon, it's used as a vocational training with even the kind of digital medium. So these young girls are trained to be digitally literate. And in the evening, it's a community space. Daytime, some areas are used as a creche where local nannies earn livelihood, and they look after these kids where both parents go out to work. Who would look after the kids? So even kids have a good quality of life. The nannies earn the livelihood, and parents are free of those worries of what's going to happen to their toddler. And it has become a full community space of all religion coming together. From a small place and recycling to now interpreting those principles in contemporary times without any devices and whatnot. This is a institutional campus, and you can see the same principles, like here, the vertically projecting profile. Here, the water harvesting from the roof into underground system. Here, cut and fill. When we took the site, we were several inches below the adjoining road, being a farmland, and road coming later. So we took a pledge, no even fistful of soil either would go out or would come in. So it was just mathematically calculated that what are the areas that would benefit by sinking just about 4 feet. So you don't 1.2 meter. So you still continue to enjoy landscape. It's not a dingy kind of basement feeling at all. Even if you're standing there, all surrounding vegetation, you can still enjoy, etc. And that is how we managed to get ourselves 8 inches above. But that cut and fill not only gave you the soil, it became also insulation in a hot, dry climate. Then checkered board planning, so outdoor spaces with mutual shading. You don't have to build everything over, because over time you can use even outdoor space. That's been the cultural learning from us, and we have learned in the lockdown that how many people kind of were so eager to step out because it was outdoor and nature that can become a better living space than being all the time within. So here is how these principles are applied. Southwest is taller, northeast is sunken in. Southwest casts the shadow to the northeast, so even terraces are used. And even the building on the southwest has the profile that takes advantage of the mutual shading. And this ferrocement roof, double, the insulation thing, double wall with cavity, ventilated cavity, three-part window. So same principles used in present time, and there is no air conditioning for this institutional space. And until recently, their monthly electricity bill for 2 lakh square foot of area as 25,000 built up, and 75,000 plot area, and 200 days of 50 people occupancy, average of only 10,000 rupee a month. Check how much electricity you get in your homes for just the home. Uh, Generative resources, so biogas to take care of the waste from the toilets, root zone, that just the plant do the needful to give you the water back as well as treat the waste. Uh, and the vermiculture, so to get fertilizer, and solar active applications with all these. Where we dug out the space, it also became a kind of a multiple use space. You can see that spaces, activities go on, but you build little and get more. This is a memorial, all done. So we say learning or inspiring or designing with nature. It's a 30 crore memorial, but only it's just because it's a large area. There are a lot of handcrafted things, etc. 30-acre memorial. It's all 5 elements. So, for example, this is Cadila Pharma, the pioneer of that. And idea was to make a public space where people learn from his life and inspire that how did he manage from rag to riches, and how it could help India to become a pharmacy giant, and how we self-sufficient, and not only that, as a result get cheap medicine so that even everybody could afford. Otherwise, tuberculosis was a rich man's kind of disease, and it was more affording to die rather than to buy expensive medicine and survive, or if at all. So anyway, so this is where you can see it's just the landform, vegetation, water, and light. That's all that does this. There are 87 plant species in the memorial immediate perimeter, and otherwise more than 120. You can see the crafts. It's also philosophy. It's talking about Indian philosophy of cyclic time. It's talking about duality of existence. It's talking about bipolarity. And all these are explained. And these are all handcrafted stone obelisk, like you do circumambulation in a temple, etc. Recycled water, including even from the factory premise, craft-based orientation, and like these are Gita shloks, etc. And this is from virgin site vegetation. And now this is 2-year-old picture, and it's even grown further. And all these have, even the exhibition building is 40 feet tall, but it's all kind of buried below the ground. And you can see, you can actually go on top like this with natural plantation and look around. And finally, the scale of a settlement. So I'm just trying to say rich or poor, small installation to interior, to residence, to standalone building, to institute in a poor context, to a larger international institute, to international memorial, and now a settlement in so housing. This is just one of the This, what I'm showing, was in the post-earthquake situation. This was the aftermath. But people lived there in a harsh climate with frugal resources, no rains, and no agriculture. And still they lived with dignity. You can see that their culture, craft, art, and architecture were so intertwined. They created with local know-how, local material, and local climate response the homes which were circular called bunga, square called choki, and they were on a common plinth. So you can see that even earthquake, this is traditional wisdom at its best. The new, house forms like this with Virat compressive strength material, unfortunately gave way. Same place, same impact. What is considered as kacha and even bank would not give you collateral are standing. This have been dated 67-year-old construction, and you can see it's unsketched. You can say top one was a fluke. Then you can see both kinds of flukes that down. Both of them are still standing and they are traditional, versus both of them picture show the disaster which have been new 3-year-old. As you can see here, that there were enough scientific reasons. One of the things of tradition is that it has been for people, by people, and for the place and context response. So they responded to that. Therefore, if we learn from that, many questions which have been perennial would have been already answered. So we don't have to invent from alphabet A. We can go on further. I won't get into technicalities, but there are enough scientific reasons why it withstood. It wasn't a fluke. And we therefore continue to have them build their own houses, but with some kind of a manually pressed ram. So you still build a clay block, fiber reinforced sort of block. Youngest of the family learned from the oldest of the family. So traditional know-how is known. You can see a small boy, 12-year-old, knows how to do this complicated roof. So hopefully coming 2 generations are in safe know-how. And because of that, they got sense of belonging. Their culture was restored. And you can see the beautiful most. If you hear Amitabh Bachchan, this is the Khushbu of Gujarat. He's asking you to come to. And clay works as an insulative thing in a very harsh desert environment. You have a very small aperture so that not to get vagaries of outside bombarding you. And therefore, at the same time, you don't even want to be in a gloomy environment. So you can see that there is a white clay of local nature and mirror. So it's not even a decor, it's a design where you can magnify by reflection the light as much. And even the intermediate technology of a smokeless stove and as a decentralized solar panel, this also won us Habitat Award 2 years ago. We were the 3 of the 100. And this is where the culture, the lifestyle was restored, and yet new things came in. Actually, it's part of a United Nations book chapter, and we were asked to visit after 10 years whether assumptions had gone wrong or right, lessons learned. And we had some of these are very recent pictures. So how people have adapted, and in fact, it has become a successful habitat. And you can see they've adapted to new technology and yet using the traditional way of life. And from where the blocks were dug, it became a natural. That was a conscious decision to pick this site. It was through barter, anyways, of 2 communities, Hindus and Muslim, Harijans and Muslim, to be precise. So this soil became the resource to make the blocks. So it was locally dug, locally used on the site. But when we dug, it's a clay strata, and with 3 inches of rainfall, this picture is just 3-inch rainfall after the big summer, and that's all that it got. And with that, they on their own, in the bigger picture, you see, started cultivating agriculture. So even in the middle of desert, you have now culture and agriculture flourishing, so they can be little more self-sufficient. So just to say, especially to the young friends, that it's absolutely possible. You have to have a right concerns that we can empower through design, and to keep in mind that what are we designing for? To improve the quality of life of the people on this planet, And to do that, what we might have to perhaps do is to reverse this equation, that rather than giving Gandhian currency the value, let's make Gandhian value itself our currency. So glamour and beauty both can catch attention, but glamour fades away in no time because it's applique and temporal, while beauty lasts forever because integral and timeless. So welcome to traverse in the intensity or immensity of time and space and notion and reality of a country like India, where we are lucky to have this accumulated wisdom over time, and we can start from alphabet Z and invent whatever that we take further it to, and rather than being kind of sorry for things, a lot of these are our wisdom rather than kind of economics or technology or whatnot. So just look at our backyard, apply it for today, future, and that would become a reality of today. So thank you for your patient listening and giving me chance to share some of these thoughts to the younger friends. Because I want to retire in the environment that you create, which should be better than what we left for you. Thank you.
Thank you so much, sir. Hello.
Yes.
Yes, sir. Thank you so much for your informative speech, especially how you clearly analyzed few contrasting words. That was really nice. So we've received a number of questions, and we would like to hear your responses from your end.
Okay.
And the first question, as I read, the similarities in all the tech buildings is due to modernization and mass production of standard products. Also, glass is the only material that can be used for mid or high rise. How can culture and tradition, which has sustainable practice, play a role here?
Yes, a good question and a very, very, very direct, without kind of going round and round answer. But can my face be brought up here so that at least my expression? I'll shut
Yes,
out
sir.
the presentation so we can have face-to-face something. All right. So you said very rightly that mass production, industrialization, standardization, you think it's a present day thing? All our traditional homes, if it is Rajasthan, it is stone. If it is South or Gujarat, it is wood, have been standardized and mass produced. But that is the kind of strict here, that it was craft-based production. For example, one carpenter would have had 25 kinds of, it was kind of an IKEA then, 25 kinds of brackets, 10 kinds of column, 5 kinds of windows, and 2 kinds of jharokas. So if I go and I say, I would like to have this, sort of a column, this kind of a bracket, this. So it would become a kit of parts, and even in the same shop with so-called craft-based mass production, my house would be unique to me, then your house again would be different than me. So, and it would have certain parity, not to feel eclectic. And yet each house was unique. You'd never had to give address as A upon 1/2 in a traditional quarter. You said, oh, that red door is mine, or that kind of a jharoka is mine, or whatever. So it respected identity. It could give personality and culturally significant kind of things, and yet through mass production. So standardization and mass production in terms of componentization, not the entire building, but components, and that you can permit and combine. How, I mean, here I would like to give my one favorite interpretation, analogy, thali versus pizza. You think thali is not mass produced? Thali is as mass produced as pizza, but the difference is in your role and plurality of your participation. For example, pizza, You're given choices of crust and toppings and whatnot, but once you exercise that, first bite tastes the same as the next, tastes the same as the last, and you eat the same pizza as I do, we can compare the experience of food alike. While in a case of thali, whether it's a southern sadhya meal, whether it's a Maharashtrian thali, or whether it's a Gujarati thali or a Punjabi thali, doesn't matter what the taste or the kind of content. It's a kind of a concept that I'm talking about. Concept of a complete meal in case of pizza versus concept of a combination meal in case of thali, where everybody is served the same ingredient. But first pluralism is that you are the designer of your bite. Every bite is your design. So ingredients are the same, but my first bite combination need not be the same as the next, need not be the same as the last. So we both can eat the same thali, but unlike pizza, we cannot share the experience of the food alike, because my sequence can be different, my combination can be different, and my proportioning can be different. For example, if I'm from Telangana, same thali, I might have more proportion of pickle mixed in a less proportion of rice, and I would find my spice. But same thali, if it goes to a European, he doesn't have to feel spicy. It's a wrong perception that Indian food is spicy. Ingredients are spicy, but it's a combination meal. Idli is absolutely bland, but that's why chutney, puri, or this rasam can be a bit spicier. And you mix it in your proportion. So the European can have larger proportion of rice and a dash of pickle. Even if he puts pickle, it would not be spicy. So likewise, each bite can become a unique experience, and you can keep varying the taste. So same food, even if you eat over, you would not go bored, because every day you can keep changing the permutation and combination. So both are mass production, but one culturally has come closer to the kind of individual need without being monotonous, by allowing you to be the designer. So what we get as thali in a turn becomes a raw material, and you turn it into a final something. So that's the kind of way the and same thing goes with this. All buildings we did, even this earthquake one. Just to tell you the thing, there was always this thing. Oh, it's a calamity. If you involve community, it would be endless. How can so many houses be built? And the whole logic was that if 100 families build one house to themselves versus one agency trying to build 100 houses, what would be the difference? What would be the time? And what would be the cost? Mind you, this house, what they built, and is actually now the marketing showcase for Gujarat, for tourism, and for them, it's also a supportive income generative element with homestay. Yesterday, only one of my friends from Andhra, structural engineer, Mr. Rangarao, and their team were there, and they took their dress and probably, I don't know, they stayed there, or at least they visited there, and was 75 rupees a square foot, where government stipulated minimum benchmark cost that government would give you the kind of approval for was 350 rupees. So 1/5 the cost. People culturally kind of finding it close to themselves, no mismatch, aesthetically most pleasant that you can think, and environmentally sustainable, and the cheapest by 1/5. And one of the first settlement to be ready in 2.5 months' time. So speed was also not lost. Okay. So components to be mass produced rather than the full this thing. And then you can put like brick. Do you find two brick building the same just because brick is the same? No. But you use the same engineering, you use the same material, you use the same kind of material is not the problem, but same product and put also in the same way, then also it comes the same.
Yes,
Okay?
sir. Thank you. Due to the shortage of time, we'll mail you the rest of the questions, sir. So
Okay.
please take some more time whenever you're free so that we can post it on our Instagram page.
Perfect.
Okay. We're truly grateful for the time and effort you took to share your thoughts, sir. Thank you so
Pleasure.
much.
Thank you. All the best. Bye-bye.
Thank you, sir. Um, don't forget to share your feedback, guys. Take out your smartphone and scan this QR code, or click the link that appears and fill in the feedback form. And don't forget to follow us on Instagram. It's a sketch and yes. Now we're finally here to the concluding ceremony of India's first digital youth conference, A-Sketch EduCon 2020, planned by a team of 22 students of different colleges across India and a team of 112 campus ambassadors under the mentorship of Ibrahim Sadqatullah and A-Sketch EdTech Foundation. I'm deeply gratified by the thoughts each presenter has shared and as a recall of our sessions and to what we've grasped. I would like to thank Dean D. Crust, sir, who talked about our role in forming a better society, Architect Yashwant Ramamurthy, sir, Architect Satya Prakash Varanasi, sir, and Architect Haripriya, ma'am, for sharing the perspective of design concepts in architecture by exhibiting their projects and explaining conscious intervention of things around us. Also, our panel discussions of women in architecture, thanks to architect Aarti Nagpal ma'am, who threw light upon salary equity in field, architect Sumit Kaur ma'am, who spoke about believing in self and freedom, architect and Professor Kamini Singh ma'am about increased ratio of women practicing architect Professor Kamini Singh ma'am, who about increased ratio of women practicing and studying architecture and how well they can manage. Architect Pallavi Anchuri ma'am, about management of house and studying. Also, architect Satya Prakash Varanasi sir, who exemplified architecture with ecology and how to blend past and present. Last but not the least, the final speaker of day one, Professor Krishna Rao Jaisam sir, who shared an open dialogue on our theme. Moving on to day two, I would like to thank architect Meenakshi Dravid ma'am, who discussed the architecture inspired by nature with beautiful examples, and young architect Farzeen Rahman sir, who spoke about how thesis goes on and the important factors of it. Coming to the next panel discussion, should you drop out of architecture? I'd like to thank architect Dr. Babar Zaman sir, architect and actor Kamal Kamaraju sir, architect Karthik Mahon sir, who shared their life experiences, different art forms, and how to follow passions in life simultaneously. Also, architect slash engineer S.P.Anchuri, sir, who spoke about structures and architecture with great examples. Last but not the least, the final speaker of today, architect Yatin Pandya, sir, who threw light upon architecture inspired by nature with beautiful comparisons. Also, special thanks to architect Mahesh Bangat, sir, assistant professor BNCA Pune, for all his services and tremendous help and to keep the expert talks and discussions alive. We also thank our official design partner, DigitoMade, which is a digital design startup led by Jeeva Nandam from Alim Muhammad Saleh Academy of Architecture and his team from Chennai for their beautiful flyers. Before I mention the core team and all the members, I would like to thank and speak few lines about A-Sketch, the reason we are here today together. The spirit of A-Sketch EdTech Foundation is towards the reinforcement of student community. We believe in balancing creativity and transformation. It's the brand known for its vision to develop and bring out hidden talents, ideas, new entrepreneurial skills, and different capabilities. We believe in fostering a culture of opportunities and work mainly for the architectural student community by encouraging them to cultivate their talent and skills and also empower educational progress and professional growth in them through our several initiatives. we contemptually announce the student base of A-Sketch EdTech Foundation is currently spread across architectural colleges in 20 Indian states. Now, whose thought or dream was this? Who's the one who worked day and night towards it? Well, it's our founder, Ibrahim Sibkatullah. Though the team works with all the determination, there is always a captain behind us who ties the entire team together, acting as a binding agent, if I must say, and making a team what it is. He's our mentor and the founder of A-Sketch EdTech Foundation, Ibrahim Sibkatullah, who himself is an architecture student currently in his 4th year. As an architecture student, he started his entrepreneurial journey by making study notes and sharing it among his friends from other colleges. His notes started spreading across Telangana in no time because of the content quality and standards. That's when he realized the need to connect with students with each other and form a knowledge sharing platform on WhatsApp and Telegram. He also launched an Instagram page named asketch_India to help young artists and students promote their artistic and creative skills by featuring their work and also by promoting their social media pages. So that's how asketch founded. And that was in the year 2017. And today, in just a short span of 3 years, his dedication and his skills pushed this platform to a whole new level. What started as a community for architecture students in Telangana now has its branches spread up to 20 states across India, connecting students with each other, thus creating India's first digital youth community that connects students from all over India and promotes sharing and unity. A genuine thanks to Ibrahim sir, who created this platform and given us this opportunity to be a part of it and who guided us throughout. Now, I would like to thank the core team who made these events happen. These members aren't any professionals, but just architecture students from 2nd, 3rd, and 4th years. So I hereby read out the names. Abrar from Deccan School of Planning and Architecture, Arvind Parthasarathi, JNIS Hyderabad, Adhrigna VSAP Vijayawada, Aziza from Deccan School of Planning and Architecture, Dhanusha from VSAP Hyderabad, Ilesh from RDS Padmavati School of Architecture, Chennai, Harshita from JNFAU, Hetvi from Marwadi University, Gujarat, myself, Shravani Kisara from Sri Venkateshwara College of Architecture, Hyderabad, Taha from JNFAU, Nomeshwari from Sri Venkateshwara College of Architecture, Himaja CSIIT, Jahnavi Patel CSIIT, Ismail Niasis College, Chennai, Madhura Vishwaja CSIIT, Meghana VSAP Vijayawada, Neha Maestro SPA, Prerna Aurora Design Institute, Shanmukhi Aurora Design Institute, Mohammad Shahrukh Aurora Design Institute. I also thank the 112 campus ambassadors who helped solve tasks at every step and mainly bridge the gap between the students and asketch Foundation. To end, I'd like to thank everyone present here and wish you all a great weekend ahead and hope to see you all in further such events. Thank you so much.